So now we will see the effect size. In the previous one also, like we have used log or odds. So you can use the relative risk also. But we are not going into the detail. Why? Because relative risk, again, that back transformation of relative risk to risk is, or that option is not there. But I will demonstrate it since it might be a, okay, it is, I have closed that. Okay, let me show that again. It was on day 4. So day 4, if you go for this event number, and then I'll go to this. So this you can see here, minus 66. So instead of, if you come to this model option here I will change this to this, and then instead of log odds, since it is a prospective, all of these are the randomized control trial. So if you want, like, it should be a risk ratio, you can click, instead of odds ratio, you can click to the risk ratio. But in the risk ratio, this option of back transformation of log odds to odds ratio, that is not there. So this 0.49, this value, this is the log risk ratio, which you can see here. That the average log risk ratio based on random effect model was 0.49. So now if you have to convert it into the risk ratio, then how will you do that? Here, in this case, it is not possible. So you have to go on the log transformation calculator. So if you see this value, it is 0.49, and it is like 0.92, 95% is 0.92 to 0.06. So that you have to enter. So what I'll do, I'll go to this log calculator. This you can get from calculator.net, and it is an exponent calculator. So you have to use E as a base. So put this E as a base, and then here you can put the value. So the value was 0.49. So I will write 0.49 and then calculate. So your risk ratio will be 0.61. Similarly, the upper and lower confidence interval also you have to type. So it was 0.92. If you press calculate, it will give you the lower confidence interval, which is 0.39, and the upper CI, it was 0.06. So it is 0.06. If you calculate, it will be 94. So similarly, in Jamovi, if you use the risk ratio, this log risk ratio, then the back transformation option is not there. Maybe someone will add it, because I said that people are writing the commands and people are like improving the modules, because this is an open community and everyone is like doing the coding using the R. And then this option you might get in few months. But currently this back conversion of log risk ratio to risk ratio option is not there. So you need to do it using the calculator.net or like that. Okay. So this was the one point which we wanted to add. Rest of them, it is okay. So now coming to the effect size, or you can go with the issue of calculating effect size. But again, for effect size, you need the two boundaries of the confidence interval, like the lower and the upper confidence interval that we'll see. So effect size, we all know that what is the effect size. Generally, there are various effect size, and it is a term when you like convert the various outcome measure into effect size so that you can compare these effect size with each other. Just as an analogy, imagine we are trying to compare the price of a cup of coffee in all these countries. So you can say there's a Japan, France, UK, India, Brazil, Australia, South Africa, Canada, and Switzerland. And you can say in their local currency, the price of the coffee is ranging from, you can say 5,000 in South Korea to, like, let's say it is least in UK, which is 3 euro. So I cannot infer how to say like where coffee is costly or where it is like less more affordable. So how do we generally do it? We convert it into a US dollar. So if you convert that into US dollar, you can see here that now you can easily say that in case of if you see the highest one, it is in the Switzerland, which is 5.3, and the least you can see in the 1.2, which is in the Brazil. So now you can compare and you can infer regarding the price of a cup of coffee. The similar concept is there in the effect size, and you see that generally the researcher, they report the various effect sizes. So in this case, now we have applied the exchange rate to convert the each currency to the US dollar so that we directly compare the cost. Now, in case of this probiotic and diarrhea meta-analysis, we have gathered several studies, let's say 2022, but the outcome, and you will find this problem in your meta-analysis, that the outcome reported in these studies are in a different way. So how to do that? Study A probably has reported the mean difference of diarrhea, mean difference in the duration of diarrhea between the probiotic group and the control group in ours. The another study has reported the reduction in diarrhea duration as a percentage, the way we have seen on fourth day. There's another study who has used probably, let's say, they have seen the stool frequency, that Bristol scale. And in that scale, they have measured the stool ranging from 1 to 10. So their outcome is different. And there was another study where they have seen the proportion of children whose diarrhea got stopped. So that's why you can see that in all these cases, and there will be many more outcome, and it will be difficult for you to compare in terms of outcome. So how to do that? So generally, we can make these results comparable by using something known as the effect size. So now what is the effect size in meta-analysis? Generally, it is a quantitative measure which reflects the magnitude of an effect or association between variable. And we combine we can compare like US dollar. If you convert that into the US, not US dollar, sorry, in the effect size, then we can compare the individual studies even if the outcome measurement is different. So what is the importance of effect size in meta-analysis? Generally, this provides a standardized way of measuring the outcome like it standardized the different metric. Like we have seen, one person is using as a scale, the other person as a mean duration, one person as proportion, other maybe as a risk ratio. So all these diverse kind of outcome, if you convert that into effect size, then it gets standardized. So what are the common types of effect size in meta-analysis? So like mean difference, again as effect size, standardized mean difference, odds ratio, risk ratio, hazard ratio, and proportion. Even proportion is a effect size. So how to choose like which is the right effect size or which should be the measure of your meta-analysis, doing the analysis? So first you have to see what is the outcome in your case, the primary outcome. So the entire meta-analysis, it gets driven by the primary outcome. So which aligns with your outcome, like whether it is a continuous or a binary or a time to event, and the study design, of course, because there are some study designs like, let's say, analytical cross-sectional or case control, where you want odds ratio to be more appropriate as compared to the longitudinal studies or prospective study. Someone knocking at the door. Which are suited for the longitudinal studies. And depending on the heterogeneity also, like if studies are using the different scales of measurement, then also you have to standardize it for a comparison of the various studies. So how to do these transformations of the effect sizes? So certain effect size like proportion or hazard ratio, they often require transformation. Why? Because if you see, they don't often require, you see their like normality, by whether they are normally distributed or not. If they are normally distributed, no need to convert them into the log. If they are not, then you need to convert that into log. And after pooling the result, again, you need to back transform the effect size to interpret the result. So interpreting, how do we interpret the pooled effect size? So basically the pooled effect size again, in if you are doing the log transformation, which we have seen with the log risk ratio and the log odds ratio, that in case of a JAMOV, it gives you in the form of a log odds ratio, but there is an option of converting that back to the odds ratio, where in case of a log risk ratio, that option is not there in JAMOV, so you need to do it on the calculator using the calculator.net, using the E exponent as a base. So this was regarding the so now we'll see. So this was regarding your effect size. Now coming to, so we will now just demonstrate you the meta-analysis of proportion and the meta-analysis of the hazard ratio. So suppose in the same, using the same example, which is the pool, all these cases where if I have this data, how many of the studies, in the various studies, how many of them have used the probiotic? Let's say generally, because its proportion will be a cross-sectional survey. So in a cross-sectional survey, if that study reported that out of 300 people suffering from diarrhea, how many of them have used the probiotic? So let's say these are the dummy data. Like we have created this just for a purpose. So you can see like Basu et al., he has reported that out of 500 people suffering from diarrhea, 125 people have used it. Similarly, 300 people, 90 have used, 45 out of 50, that's how. So it's the proportion. And then the other one is the effect size. So if I have to do the meta-analysis of hazards ratio, which is again an effect size, so how will I do that? So suppose it is a time to event study, because generally hazard is calculated in time to event study. So if my this survival outcome, it is the you know incidence of a reduced diarrhea or a diarrhea less than 3 per 24 hour after 4 days, let's say. So if my question is like, do children receiving probiotics have a reduced hazard of experiencing prolonged diarrhea compared to those receiving the standard treatment? So the outcome here is the hazard ratio, and the focus here is on the time to event outcome, and the event here is the resolution of diarrhea. So how will I interpret the hazard ratio? If it is less than 1, I will say that the probiotic is associated with the faster resolution of diarrhea. And if it is more than 1, then I'll say that, the standard treatment is better. So this is like this, again, this data we have created. So this is this first column, if you see, this is the column of hazard ratio. This is the lower confidence interval. So in case of effect size, you need these two measure. One is the effect size, the upper CI and the lower CI. And using that only you can do that. And then I have calculated the standard error. From this, we will tell you the formula. Then again, if it is, you just see the distribution of this outcome, which is the hazard ratio. If it is normally distributed, then you don't need to convert that into the log. But if it is normally distributed, if it is not normally distributed, then you need to convert it into convert this into the log HR, the log of the lower confidence interval and log of the upper confidence interval. Here, like you can see, it has been done on Excel, but you can do it in the JAMOV also. We'll see. So when we say how to calculate this standard error, so standard, there is a formula of standard error from the upper and lower confidence interval. So when we say that about 95% of confidence interval, how do we write? So we say that we say that mean plus minus 1.96 multiplied by SC, that is your confidence interval. So how we will take the upper border of the confidence interval by mean plus 1.96 into SC and lower border by the mean minus 1.96 into SC. So if you equate this, like if you do that upper minus lower, this will give you like mean plus 1.96 into SC minus mean 1.96 into SC. So this will get cancelled, mean, and this whole will get doubled. So your SC will be upper limit of confidence interval minus lower limit divided by 2 into 1.96. So this formula, because you have to calculate the standard error. Generally, it is not given in any of the study, but they give the upper and lower border. So you can calculate the standard error using this formula. Okay. So if you are okay up till this point, then I'll show it in Jamovi and the Excel. Complete silence. Can anyone say yes or no? Do you need,
Yes. Continue.
Continue? Okay.
Continue.
Akash has said yes.
Yes.
Okay, thank you. So now I'll go to the Jamovi. Okay, Excel. Yeah, I'm coming to day 5. So this was the data which we have just, this is not the actual, like it is just a dummy data. So this was like all the study, then total cases that we have taken the snip on that PowerPoint from this Excel sheet. And these many people out of total they have used. So this is a proportion. You need to enter the raw data and it calculates the proportion. Coming to the other Excel sheet of the meta-analysis and hazard ratio. So there here you can see this, I have this, generally this you should have. The hazard ratio or the odds ratio. This one. This column you should have, this and this. This log transformation, generally how it is done. In Excel, if you want to do it, if you press log ln, then this comes. So I have done in the upper, sorry. In this column, I need to do row ln. Natural log we have to do. Select this and press enter. So it is again this value. And if you double click on this, this will be populated. Similarly, you can do it for the lower CI and upper CI. This is not needed always, this log transformation. This is needed only when the data is not normally distributed. So I'll go to the Jamovi then. So this is my meta-analysis for proportion data. How this is very simple. You just have to, this is the simplest. Go to the measure and here you will find proportion. So click on this proportion. And then you can like put this study here, total case in the total sample size and frequency of the event in probiotic used. In the model option, again, you can change. And here you want to use as a raw proportion. You don't want like log transformation. Currently, I'm showing with the raw. And then you can see here. So 30%, the overall pooled estimate was 30%. Like 30% of the people, they have used the probiotic in the treatment of diarrhea. The CI is 0.272, 0.33. If you see the heterogeneity statistics, you can see like I square is very high here. It is again like not very high, less than 75%. Up till that, it is okay. 67% is there. This is again, there's a heterogeneity because P is significant. This is again, H square is more than 1. So there is a heterogeneity. And if you come down and see this, so this you can see in prediction interval, you can, in the plot, you can click on this prediction interval, and you can click on this model fitting weight, so that here it will show you the overall pooled proportion, which is the 30%, and 30.28 to 0.33. And then publication bias, you can see the number of studies. So if you see the data, or from above also you can see, so 3, 3, 6, so studies are more than 10. So you can go ahead with reporting of publication bias. So first should be the significant, that means there is no publication bias, and rest two are not significant, that means there is no publication bias. You can see the funnel plot symmetry. Although this funnel plot symmetry tells you both about the funnel, this publication bias and heterogeneity also. Since there is a heterogeneity, you will see that they are not symmetrically distributed. So, but it doesn't give you the write-up. If you see in the mean and odds ratio, you were getting the write-up. But here in this case, the command or the codes which they have written, it doesn't give you the output. So you have to write it. And this one was, that's it. So this was for the proportion. It's very simple. Proportion is like, you can start doing, if you don't want those, like where you have to search for data, you can start doing a meta-analysis for simple prevalence studies. And then you can pool the evidence. And then coming to the this event number, no, not this, hazard ratio. So effect size, this was like HR, lower CI and upper CI. So I'll just check whether this is normally distributed or not. So I'll go to the analysis, exploration, check for the descriptive. And in descriptive, since the sample is less than 50, so we can go with the, I will check of this HR. Put this here, go to the statistics. Maybe rest people who are not familiar to the JAMOV, you can see our other videos or anyone's video on JAMOV, the basic analysis. So in this case, this Shapiro-Wilk, it gives you objectively the criteria. So if you see the value of Shapiro-Wilk, this p-value, it is not significant. So that means these hazard ratio are normally distributed. In that case, you don't need this log transformation. Okay, so I will just move this back. So how I have calculated the standard error? Yes. Can someone say how I have calculated the standard error? What is the formula of standard error? So it is the upper CI minus lower CI in the numerator, and denominator it is 2 into 1.96, which is 3.92. 3.8, not 92. I think it's 3.92. So I will put the study label. If you go to the data set, you can apply here in the JAMOV also if you don't want to do it in. Like I have done for this, if you want to calculate the SE, you can go here and you can click on this compute. Go to this compute, and this is, let's say, SE, standard error. You do this function drop down menu, select the upper CI, double click, minus lower CI, and then make it in bracket. And then divide this by 3.92. 3.92 is 1.96 multiplied by 2. So it is 3.92. So you can see this value and this value is same. This SE1 and SE8 is same. So either you can calculate it in Excel or you can do it here in JAMOV. Now what option will I choose? So I will go to this measure, and here I will click this effect sizes and sampling variance. So I'll click on this effect size and sampling variance. I will put, so since it is normally distributed, I'm not using log. So I'll go to this study label first. Then I'll move this hazard ratio to the effect size. And here variance, here you can see it is asking for either variance or standard error. So I have calculated standard error. So I will move this either SE or SE1 here in this box. And here in the model option, by default, it is clicked sampling variances. So from sampling variances, you need to click this to the standard error because I have used standard error as a variance. And then option again, you can change this. Again, if you come down, see the plot, click on the prediction interval, model fitting weights, and then wait for the result. So you can see here that it is giving 0.86. So hazard ratio in the group which is in getting the intervention is 0.86. That means 14% less hazard in the intervention group. And the lower and upper CI you can see, if you see the heterogeneity statistics is again 66%, showing that it is a high heterogeneity. H square value is also more than 1. And the Q statistics, the P value is significant. If you come down, you can see the summary statistics. So in this case, when you have to report it in the publication, generally you see the line which is drawn here, that is at the 0. So since it is a effect size, so it starts, this is 1. So you need to draw a line here at 1. Whenever, so you have to copy paste in Word and then draw a line. Like I'll show you, we had to do that for our publication since Jamovi always gives you need to say like which is 1 because hazard ratio, you have to draw it like this. So you have to vertically, I'm not able to do it very perfectly, but like this. And then towards the right side, you have to write like towards the left side is favorable outcome and towards the right side as not favorable outcome. We'll show you the way we have designed. And this is the publication bias. If it is significant, saying that there is no publication bias. Here in this case, we will see that these two are significant, saying that yes, there is a publication bias. So you can see the studies. Although since these studies, we have created this data, as a dummy data. So that's why you can see there is a publication bias. And there's no need to comment on the equivalence test. So that you can leave that for now. And there's no write-up also here. So write-up you will see only in case of a dichotomous outcome and the mean NSD. For rest of the effect size and the proportion, generally the Jamovi doesn't give you the write-up. So, but on the basis of the same which you have seen, you can do the write-up. And here you can say that in case of a so if you see here you can see the plot diagnostic. There Jamovi was writing like which were the study which were outlier. In case of effect size, you can see the Cook's distance and the studentized residual. So this is the one you can see, the first one. So all study that seem, I think there is no study where it is going as a outlier. The externally standardized studentized and the Cook's distance also you will see that it is okay. No red color is there. So this is how you can do the meta-analysis of effect size. Is it okay up till this point? Can someone? Yes, okay. Thank you. So if you are okay, like we have shared the data, I think, have we shared this dummy data? We have shared this dummy data sheet also with you people. So you can just practice the interface. If it is a hazard ratio or if it is you can take odds ratio also. Like in our air pollution, we'll show you the paper. There we have, we tried for other outcomes, but we could not get. So we have taken odds ratio as a measure of this effect size. And we have taken the lower and the upper border of the odds ratio, and we have calculated the standard error the way we have done it here, and then we calculated the meta-analysis. And there, because we could get both HR and OR, so we did the meta-analysis of HR separately and OR separately. But again, there were a lot of errors in that paper. We will discuss that error also, which we because since we were doing it, and they were we made a lot of errors. But again, we learned from our errors. So now probably when we will do the next one, we will improve upon those errors. So this was now coming to the next session, which is on PRISMA. So we have discussed PRISMA till now also, but again, today you have to do one activity where you have to draw the PRISMA diagram. There are ways of drawing that PRISMA flow diagram, and you should know some basics of PRISMA. So now we know the full form of PRISMA. What is a PRISMA? Basically, it is the preferred reporting format for the systematic review. So we have seen all these steps. Like, we start from a defining of a research question. We have identified the key concepts from the research question. We have selected the database. We have developed the search strategy, run the search strategy, selected the article, run the screening and title and abstract screening in Ryan, and then finalized, then did the full text screening, selected the article in full text screening, did the gray literature search also, seeing the registers, seeing the back citation and forward citation, seeing the websites and the other sites of open gray like thesis database or some other sites. And then we have decided on these are the full text. We have retrieved the data. We have performed or got performed that risk of bias assessment. And then we have performed we have decided whether we can go ahead with meta-analysis or we should stop at this point. So now if in both the cases you need to report it using the PRISMA guideline. So PRISMA is for the reporting. We'll see what are some misconceptions that is there with the PRISMA. So this PRISMA, again, everywhere you will see this PRISMA in the form of a flow chart. But this PRISMA is more than this flow chart. So this PRISMA is the preferred reporting items for systematic reviews and meta-analysis. And this is a standardized method given by Cochrane to describe how studies were identified, how they were selected, and how they were analyzed for the inclusion. So it comprised of 3 elements. It is not only the flow diagram. Generally, wherever you see, they talk about this flow diagram and you will see this flow chart. But there are the other 2 components. We have shared with you people the version of PRISMA, which is I think 40 pages or something. And there is a statement of this PRISMA, and then there is a checklist. We have shared the checklist also, which is a 27 item checklist. And you need to prepare this manuscript using that checklist. That helps. That is quite helpful. Even the abstract, the file which has been shared with you people, there is a PRISMA checklist for abstract also. So all the abstract and this systematic review and meta-analysis, which is the SRMA, should be drafted based on that checklist point. So now coming to this. So this, since beginning, we are seeing this flow diagram. So we will be discussing currently, I am focusing on this flow diagram. After that, I will show you that 27-point checklist also. So this flow diagram, if you see this, there are 3 parts of this flow diagram. So this is the first one, which is if suppose I have conducted one study on one systematic review and meta-analysis, and after 2 years, new studies got added. And I want to review again. I want to add new studies to my previous conducted meta-analysis. Then I will use this one, like how many previous studies I included. And here, you can write it like studies included in the previous version and reports of the studies included in previous version. So you just have to give these 2 numbers. The last one, this one, what we right, we reach here, you have to start with this number in the previous study and then you add it here. And then you start with this new. That's why you will see in the bottom, in the box, here you will find in review, but in the Prisma new one, here they write new. So don't get confused with this new word. New means they think that you have not done any previous meta-analysis on the same topic and you are starting afresh. That's why they call it as a new. So you start again. Here you see that there are three terms. There is a term which is a record, there is a term which is a report, and there is a term which is a studies. Yes, you can see new studies. Okay, so now how to differentiate between these three? We'll see that. And then again, there is a third component, which is the gray literature. So gray literature, you don't need to put it in the title abstract screening. You only need to report the full number, and out of that, how many were considered for the full text screening and assessed for eligibility and then included in the final systematic review. So now we need to understand the difference between what is a report, what is a record, and what is a study. So let's start with the record, because record is the first database which we have to enter in the Prisma. So record is like, you can understand these record with the metadata or the file like NBIB file, or in base it was like RIS file. So all that metadata which we retrieve from the database, that is known as the record. And record may be a duplicate one, because many, you can see that if you are extracting from PubMed, from Medline using PubMed and using Ovid, then definitely there will be a lot of duplicates, because both are going through the same database. Again, in base or Web of Science also, you will find a lot of duplicates. So it is unique only when the content differs. Otherwise, for example, this record refers to the individual entries or citations. You call it citations also, or the metadata. So the individual entry of that particular publication into these databases, it is known as the records. So whatever you get from the database or registers in the form of a NBIB format or RIS format, that is known as the record. Like for example, during systematic review, I may get one record at two places. So in record one, that Smith et al., I have gotten this from Journal of Clinical Nutrition, and another I got this from a PubMed also. So again, but these are duplicates. So I need to deduplicate it, which we have done it in the Ryan. So this is known as the records. Okay. So records are the citations which we receive from the various databases in the RIS or the NBIB format, and there are high chances of its duplication, because every database enters it with the different characteristics, and that's why there are so many duplication. So this is known as the record. The second term is report. Now, what is a report? So basically, report is the published manuscript. So individual publication is known as the report. Now, what is a study? So a single study can have more than one report. Like, you often have faced that whenever you go to the conference, there is a study and you present a smaller part of that smaller part of study. Let's say you present only one objective in one conference, and rest two objective you might present in some other conference. But there will be two conference publication from the same study. Again, many people, they do the piecemeal publication. Like from one thesis or one study, they publish two papers. One paper as a preliminary, and then they do some secondary data analysis, and then they again publish a paper. So with one research or the one conduction of research or study, you might get more than one report in the form of a conference proceeding or in the form of a two publication. Okay. So then you will call it as a three report, but they are the report of the underlying same study. but they may differ in the type and amount of data reported. Yes, because initially when you have presented in the conference, you have presented it on 120 subjects. But by the time your thesis got completed, the number of samples were 300. So the actual paper which you will publish and in the conference which you have published, the number will be same. They may differ in the type and amount of data. So report is like, definitely it's an individual publication. But how it is different from study? A study is a larger part, and from a single study, you can publish many reports, right? So a unit of meta-analysis is the study. It's not the report. So if you see, so study refers to the research project itself, like thesis, where you get approval of the IEC with a single IEC. That's why you say that yes, in our journal club also, many people present the journal, and you will see that on the single IC, they publish 2-3 paper, and that's the classical example of a report on a single study. So this study refers to the research project itself, and one study may be reported in multiple reports or paper. So like you can see this in example that probably the trial is reported in report 1, which is the primary outcome, but the secondary outcome and maybe the other thing they have reported in the other reports. So in PRISMA flow study, like I said, the unit of analysis is the study, the one included or excluded based on the eligibility criteria. It's not the report. So you need to, that's why you will see in the PRISMA flow. I'll show you. Oh, it is there. So PRISMA is the preferred item for systematic review and meta-analysis. Why it is not coming? This one. This is showing here in the... no. Yes, right. Let me show you the... No, this is not the same. Na? It is going to the next slide. Let me... The picture can't be displayed. Okay, let me close this and then again open this PowerPoint. Because this is not showing up. I'm sorry for that. Let me close on this. Don't save. Yes, now it is showing. So now you can see here the first which this Prisma writes, it's the records. So that's why in records, whatever number you have got from this RIS and NBIB file, you will write that. Total number in the database, the first one, and the registers. Then again, it asks for this record screen. Again, it is using the term the records, because here you will do, after this duplicate, you will do the title abstract screening, and then you will exclude the record. Now, after that, then it will be the report, because it will be the individual studies which you have taken in the full text. And then you will assess the reports for eligibility. But after that, you see that they are citing that new study is included. Then you see many times what happens, that the study and the report, they are same. Generally, they are same. So, but in both the cases, you need to enter the same number, the reports and the studies. And then if it is different, like if in a single study, if there are 2 reports, then these number might vary, but generally they are the same. And then coming to this new studies via here, that website organization citation. Again, how many you have sought for retrieval, how many you did not receive, assessed for eligibility. If they were excluded, what was the reason of those exclusions? So now again, going back to PRISMA. PRISMA is again, it is a preferred reporting item for systematic review and meta-analysis. Again, it is a widely used guideline for reporting. Remember, the key term here is the reporting. I will show some misconception around this PRISMA, that they write that it is a way of conducting. No, conduction, it doesn't give you any guideline for conducting the meta-analysis. So if you see the PRISMA chart flow, it has got like components. It has got identification, which we have seen. It has got a screening phase, eligibility, and then finally included. So it tracks the progress of studies throughout the review process. That's why you should maintain a log. Otherwise, it will be difficulty for you people to fill this. So identification, then comes the screening, then the eligibility, and then the inclusion. So if you see, like, purpose is basically, since beginning, we are talking about this purpose and the intent of systematic review and meta-analysis, and how it is different from the narrative review, that the transparency. That means the search strategies which you are adding it as a supplement file, if someone else will perform the same search, he will get the same number of article, or probably few more, because there will be time gap between the reviewer doing it and between the author doing it. So again, it ensures transparency, and it gives you the guideline how to maintain the record, screen, excluded and included, and it helps the readers to understand the process. So there was a earlier PRISMA guideline, but in 2020, the PRISMA has updated the guideline. And what are the key updates? So basically, pre-screening details are also available, such as the duplicates removal, and they also show the reasons for the studies which you are not including in the full text review. And then there are sources like handling records are there. And again, we talked about that registries. So if you see the previous one, the clinical trial registries, that was there in the gray literature part. But now, since they have made it mandatory, so they have shifted the clinical trial registry, this thing name, from gray to the main database. So this we have seen. Identification stage, we see the number of records identified through database, number of duplicates removed. In the screening stage, we see number of records which we screen, do the title abstract screening, the excluded one. We assess for eligibility, and we include the overall number. So how to create a PRISMA flow chart? So there are 3 ways. First is you can use a app which is known as Shiny app. I will demonstrate it before you people go to the breakout room, which is a web-based app. Then it is a Word template. We have also shared the Word template with you people. You can do that. And there is an Excel-based template. Again, Excel-based template is a little tricky. So we will recommend either you do it in Shiny app or you do it in the Word format. So if you go by this flow diagram generator provided by Shiny app, I'll show you. But again, this doesn't save your version. So you need to import it in the form of a JPEG or PNG file. And again, if you are not doing it in one go, it doesn't save the result. So you need to have that data somewhere else. Otherwise, like if you are working on that, and if you just leave that and go for some other work, this will not be saved. So that's the problem. You need to do it in one go, this Shiny app. Word template is easy because it is like any other word. So you can start doing on Word also. That is also, it's very nice. It is up to you. Like today you have done some part, tomorrow also you can do the other part, and you can directly attach it in the manuscript. So there's a Prisma Word template, and it is best for offline work, and progress can be saved for future revisions. And again, Excel based templates are there which create flow diagram by entering the study data into the Excel template and uploading it into the Shiny app. But again, learning curve, as I said, it is little tricky because Excel has its own people who are very comfortable in Excel. You can go ahead, but we will advise you either you should use the word based template, or you can go with the Shiny app. So I will just these log I have we have kept. I hope that you have kept all logs since, because I mean, I hope means when you will do. Currently, definitely, since we were doing just as a part of a workshop exercise, but when you will do, actually, you keep a log of all these numbers and the date. So there are some misconceptions regarding Prisma. So misconception are like, you can see this was one meta-analysis on probiotic in antibiotic associated diarrhea. And here the author is writing that this meta-analysis is conducted and presented in adherence with the Prisma statement recommendations. Okay. So Prisma doesn't give you any guideline for the conduction of meta-analysis. Yes, definitely it gives you the way it should be reported. So this line is not okay because Prisma doesn't give you the guideline. Here also there was one meta-analysis which was on the effect of probiotics and symbiotics in children with diarrhea. And he has written that we conducted this meta-analysis according to the Cochrane handbook. That is okay, because they have conducted according to the Cochrane handbook for the systematic reviews of intervention, but they have added in the after the comma the preferred reporting item. So Prisma is, again, it doesn't give you the way how to do a systematic review, how to do. It doesn't give you the guideline. It tells you how to report it. So what is the correct way? So this article, which we have used as a reference article in this whole workshop, which is the systematic review and meta-analysis with the probiotics for treating acute diarrhea in children with, and here you can say the author has written that this systematic review and meta-analysis follow the Cochrane collaboration guideline in undertaking this review and the Prisma statement with respect to reporting. So that is the ideal way to write. You conduct the systematic review and meta-analysis using the Cochrane guideline, and you report it using the Prisma. You don't conduct it using Prisma. So now there is activity time for you people. I think, have we shared the slides with them?
WhatsApp पे activity share कर दिया Prisma का.
Numbers.
हाँ सब कुछ पूरा detail.
Okay, we have shared the numbers. So you have to create a. Okay, first, but I have to demonstrate now. Okay, first I'll demonstrate and then you people. So first you have to generate a Prisma. Generate one only. We are not giving you two. So I'll just show you.
Video बना दिया.
This is the record. This is the exercise for them, na?
हाँ video बना.
Okay, so I'll show you on some other. So you go to this and you click on this Shiny app, Prisma. But write Prisma, otherwise some other app also comes. So Shiny app, it comes like Shiny Ahuja. Prisma. So this is the like Shiny app Prisma flow diagram. You click this. And then there's a page. So it gives you some basic about Prisma, and then you have to come to this create flow diagram. I'm not going to read this web page. You have to come to this create flow diagram. So click on this create flow diagram. So now you can see that there is a window towards the left side where you have to enter the data and it will get populated here in the right side. This one. Okay. So I'll show you how to enter it. So here it is a main option like previous studies. So I am doing a fresh systematic review. So I will select this, it is not included. And other searches, of course, it is not included. Now coming to this individual databases. So I will write that I have included this individual databases. So I will click this included. And individual registers also I have included. So if you click that, you can see the database number. It is showing the individual databases also. This one. And individual registers also. This one. But in this case, you have to show here how many databases. Let's say in our case, we have done the PubMed, the Embase, and the Medline. It is writing error has occurred. So I took 4 databases, and let's say I have seen 3 registers. So you can see here that this 4 and 3, this 4 database and this 3 registers, it has appeared here. Now I need to give the detail of these. So for that, you can see it is writing here. So database you can write here. The first database, let's say it is PubMed. So I will write here as PubMed. Then it is a comma. You use its template only. Let's say I have retrieved 300 articles from PubMed. The other database, now for this, what you can do, you keep on scrolling towards the right. And then you can see database, database 2. So you come up till 2. This is database 2. So let's say it is Embase in my case. So from Embase, I have retrieved this number you have. So you can keep these numbers ready at one place, or two person can sit. One person is speaking and the other person can enter it. So let's say in Embase, I have got 455 articles. No, that is there. Yes, it is there. You can see. Okay, we will increase that database and register. We'll change that later. And then you can write here in the database third, which is, let's say, Ovid. So I will write here as, maybe it is the Medline through Ovid. So through comma is already there. So I am only replacing this. So this I have written like, let's say, 433. And then again, I will go ahead. So these 3 databases I have included. If you want to include some more database, you can again like do after, you can see after this, there is a comma. So after, no, let's say, yes. So semicolon, this is colon. And let's say any other database, Web of Science. And again, it is separated by comma. So let's say 333. Yes. So you can see here that all these numbers have appeared here. PubMed, Embase, and Ovid, and Web of Science. And then comes register. So similarly, you can enter the for registers also. And later you can change the database. Since I have like 3 registers and 4, so you can write it total as 7. Okay, so here you have to write like total number which you have to calculate. And you can see the moment you change something, this app disappears. So this database, like it is the total number of article. So it will be like 300 plus 455 plus 433 plus 333 plus these number. So total record. So let's say you have taken like 3020, 3200. But again, this doesn't calculate this automatically. That's the problem. So one thing is like you can do it in the Word also. And then, so you can practice at both places. I'll show you over the Word document also. Website, let's say, this is for the gray literature. Okay, it is not there. Okay, since it is not there, so I'm just leaving that. So if you have not included the gray literature, the other searches for studies here, you can like write not included. If you write that, this will disappear. Since Dr. Shamshad is saying that activity is not there with you. And then you can come down. Again, you can write here like record screen, how many screen. So after duplicate, let's say you have screen 2600. You have excluded in title abstract screening. Uh, Probably let's say 3000, no, not 2100. Sort, that will be again too much. 2550. I am just entering some random. Here you have sort report 50, not report, you have did not get 16. You have assessed like 44, 34, and then excluded because of what? That reason you can write. And then finally, how many studies? So new studies, let's say you have included 16, and then new report again 16. But again, you can see that number, it doesn't calculate it automatically. So reviewer has to calculate it. So we made an error when we made this Prisma diagram, and then we got a comment from the reviewer to check it once again. So we again calculated that, and then we corrected that. So you need to do it at one place probably, and then keep on entering this. You can do it in Excel also, or you can like do it manually using a paper pen at one place and then keep on entering either here or in the Word document. So if this is okay, then we can go to the breakout room and you can practice this with the exercise which is there. You just need to see how it flows. Again, if you find difficulty in this, you can go with this word. I will show you. This is the Prisma exercise. This. So, but here we have this format where there is no gray literature. Okay, so it is. So in version 2, it is there with the gray literature. Here you can enter it in this form also. So in this form, you can see like it is the total number of articles from all database. If you wish to specify that, you can either enter and keep on writing, or many people what they do, they put a star mark and write in the footnote the detailed breakup of each database. So it is up to you how you want to report. Like here you can write after total 1, you can write like database 1, then again database 2, you can write the name, database 3. Similarly, in the registers also, you can write like register 1, and similarly, you can keep on expanding. So this is also a good way where it is saved. So this is one good way, because in Shiny app, if that close and if there is an error in the application, your all entered data, it goes off. So that's the problem. Okay, have you understood this Prisma? And Prisma is like for reporting, it is not for conduction. Can I see the chat? Yes, no, whatever. Do you want anything to be repeated? Okay, Tapurvata is writing yes. No. Yes, madam, at 3:36. Yes, can you say something, you guys? I cannot see your faces, so I am not sure. Okay. Then, Dr. Anand, can you open the